So in this video, I'm going to go over Chapter 7 review. So the first question asks, express the confidence interval using the indicated format. So we are given this confidence interval in this form, and we want to convert it or rewrite it as in this form. So in class, if you guys remember, we have three forms of a confidence interval. The first one I referred to it as the plus or minus form, which has like p hat plus or minus the margin of error. And then we have the interval form and then the inequality form. So in this problem, we're given the inequality form of a confidence interval where the format is this is the lower limit, this is the upper limit, and we want to convert it to the plus or minus form. So here's how we do that. Given a confidence interval, the sample proportion p hat can be obtained by adding the lower and then the upper and lower, and then dividing by 2. And the margin of error can be found by subtracting the upper and lower and dividing by 2. So let's go ahead and do that here. So p hat, which is the sample proportion, is equal to 0.479 plus 0.039. Divide that by 2, and then the margin of error is 0.479 minus 0.039 divided by 2. So let me go ahead and evaluate that here. So for the sample proportion, that's 0.479 plus 0.039. And then I'm going to evaluate. So this is the numerator here. Then I'm going to divide the numerator by 2. So the sample proportion is equal to 0.259. For the margin of error, what I can do is I can retype. I can type the numerator, or I can just go up here and then copy and paste. And then I'm going to change this to a subtraction, evaluate, and then divide by 2. Again, it's this divided by 2. Okay, so and then to complete this, the confidence interval in the p hat plus or minus the margin of error format would be 0.259 plus or minus 0.22. Okay, so that was number 1. Number 2 says the following confidence interval is obtained for a population proportion. So here's the confidence interval. Use these confidence interval limits to find the point estimate p hat, the sample proportion. So in interval format, this is the lower limit, and this is the upper limit of the confidence interval. So to get p hat, same formula that we used up here. So it would be upper plus lower divided by 2. Okay, so let me put that into the calculator. So 0.724 plus 0.688, and then divide that by 2, and then I'd get 0.706. Okay, so before I move on, I want to show you guys a common mistake I see a lot of students make using the calculator. So a lot of students make the following mistake. So say we're calculating this, we'd put 0.724 and then plus 0.688. And you know, see how it says the fraction bars here divide by 2? I see this mistake many times each semester. So some students would divide by 2 just like that. The reason why this would not give the correct answer is because order of operation is going to dictate that we're going to do this division first. So we're going to do 0.688 divided by 2. And whatever value we get here, we're going to add it to this, the 0.724. That's not the correct way to do it. So do not do that. Let me just evaluate to show you that it's not going to give us the answer that we obtained here. All right, so obviously that's not the answer. If you wanted to do it in one expression, what you need to do is separate it by parentheses. So for example, we do open parentheses, 0.724 plus 0.688, and then close parentheses, and then divide that by 2. So by putting parentheses, we're going to evaluate the sum first and then divide by 2. All right, and that's the correct answer. So hopefully that makes sense. Number 3, let's see, we have the following confidence interval is obtained for a population proportion. So we're given a confidence interval in inequality form. Use these confidence interval limits to find the margin of error. So again, we're just going to use the fact that the margin of error, given that we have the confidence interval, is equal to upper minus lower divided by 2. All right, so in this case, the upper is that, the lower is that right there. So the upper would be this, and then we're going to subtract that and then divide by 2. So let me input that in the calculator, 0.752 minus 0.724, and then evaluate and then divide that by 2. All right, so the answer would be, the margin of error would be 0.014. Okay, so that was the first 3 problems. Let's take a look at the next couple of problems. So number 4, instruction says, assume that a sample is used to estimate a population proportion, P. Find the margin of error that corresponds to the given statistics and confidence level. Round the margin of error to 4 decimal places. All right, so number 4, we're given a confidence level of 95%. N is equal to 380. X is equal to 50. So we are looking for a margin of error for a population proportion. All right, we have, so the formula for a margin of error is z sub alpha over 2 squared. No, I'm sorry. The critical value times the square root of the sample proportion p hat times q hat divided by n. So let's see what values we have. So the critical value, we do not have it, but if you guys remember in class, 95% is one of our common confidence level, and the critical value does not change. The critical value for a confidence level of 95% is 1.96. And what I mean by it doesn't change is, given a confidence level, the critical value when we're dealing with a z distribution does not change for that confidence level. So for example, the confidence level of 99%, the critical value for a z distribution would always be 2.575. So I really recommend you guys write these down. They come in handy and they come very useful. Otherwise, you'd have to calculate it all the time, which you don't want to do because it's going to save you a lot of time if you just write these 3 down. Okay, so the value there, the critical value for this problem is 1.96, and we're going to multiply this by the square root of p hat. P hat, we are not given p hat, but we can easily figure out what p hat is. P hat is x over n. So in this case, 50 over 380. All right, so let me just evaluate that real fast. So that's 50 divided by 380. And let's round this to 4 decimal places as well. So this is approximately 0.1316. Q hat is always equal to 1 minus p hat. So let's do that. So 1 minus 0.1316. So Q hat is approximately 0.8684. All right, so let me just put those 2 values in. So that's 0.1316 times 0.8684. And then we're going to divide by n. So n is 380. And then once I evaluate this, I'm going to round to 4 decimal places. So let's see what we get here. So we're going to get 1.96 times, and then the square root is second x squared to get the square root. And so we're going to do 0.1316 times 0.8684, and then divide that by 380. All right, so I'm going to evaluate. So the margin of error would be approximately equal to 0.0340, rounded to 4 decimal places. So now you might ask, when I was evaluating this, how come I didn't separate this with parentheses? Because when I divide. The reason is you only get into that trouble where you may not get the correct answer when it involves multiplication and division. I'm sorry, when it involves like addition and subtraction mixed in with multiplication and division. So if it's just division and multiplication, as we have here, right? We have multiplication here and then division here. It's not going to affect the answer. It's going to order of operation is going to work correctly, and it won't affect your answer. Right, so just a heads up. Number 5. Number 5, we are given that use a given degree of confidence in the sample data to construct a confidence interval for the population proportion P. So we are trying to construct a confidence interval for a population proportion. And I've got the notes written down here, right here. So anytime we're trying to construct a confidence interval, using the calculator, the TI-84, here's the functions that you should, here are the functions that we would use. So for a proportion, so if we're constructing a confidence interval for a proportion, there's only one function in this chapter. That's one prop z int. Again, the prop here stands for proportion. The int here stands for interval. If we're constructing a confidence interval for a population mean, there's two functions. There's z interval and then there's t interval. Z interval is where we know sigma. Sigma is known. And the t interval, we use a t interval when sigma is unknown. And again, sigma is the population standard deviation. So in this problem, the problem that we're working here, we are constructing a confidence interval for a proportion, population proportion, which means we're going to use one prop z int. All right, so for one prop z int, those are the three values that we need. X in confidence level. So let's navigate to that, see what we get. So we're going to go stat, we're going to go to test, and we're going to go all the way down to one prop z int. There it is. And X is 30, N is 56, and then the confidence level is 95%. So we're going to put that in as a decimal, 0.95. Confidence level there just happens to be 0.95. There it is. And this is the lower bound, this is the upper bound. So the instructions does not say which decimal point to round to or which place value to round to, but I'm going to round this to 3 decimal places. Now on the test, just follow the instructions. If it's multiple choice, then you should just choose the answer that you'd get there. All right, next problem. So instruction says find the minimum sample size required to estimate the population proportion. So when estimating the population, the minimum sample size, there are 3 formulas. And just look for the notes where I have those formulas. I have it written down somewhere. There it is. So for minimum sample size, for proportion, so when you're trying to estimate a population proportion, this formula would give you the minimum sample size, meaning the minimum number of values you should sample so that you would get an accuracy to a certain confidence level and to a certain margin of error. There's 2 formulas for the proportion because the first one here is where we have an estimate for p hat. So there's an estimate for the sample proportion. You'd use this formula here. If there is not an estimate for p hat, the sample proportion, you'd use this formula here. All right, and I believe in the problem that we have here, we are dealing with a population proportion. We're trying to estimate population proportion. Number 6, we're given the margin of error, confidence level, and p hat and q hat is unknown, which means we're going to use the second formula. And that formula is